Okay, Algebra 1, I did a couple of examples that are similar to the types of problems you're doing for homework this weekend. This first one says Sam earns a salary of $35,000 plus $200 for every car he sells. Write an equation representing Sam's earnings for the year. Okay, so the thing that no matter, remember there's always, the y-intercept is always the thing that no matter how many things are sold or how many things are, whether it's sold or the number of items or the number of tickets, whatever it is, there's always going to be something that will never change because of how many things are sold. And in this case, the salary. Sam's salary will never change depending on how many cars he sells. That is going to be your y-intercept because he will always get $35,000 whether he sells one car or whether he sells 500. So when we go to write our equation, I'm going to go ahead and put in plus $35,000. Now, so again, the y-intercept doesn't depend on anything else. It's just out there and it's not going to be affected by anything. Now, the second thing you have here is that he earns $200 for every car he sells. So our variable, the x, is going to be the number of cars he sells. So I'm going to put that in right here, and then we're going to say 200 times x since we don't know how many cars he sells in this statement right here. And what we wanted to do first was write an equation representing this statement. So here is our equation. Y is going to be Sam's earnings. Okay, that's how much he's going to earn. His salary is the y-intercept again, because no matter how many cars he sells, he'll always get $35,000. And 200 is per car, so we multiply that times x, which is going to represent the number of cars he sells. And so you have an equation that you can use to solve the next two examples. So on this first example, it says, how much would Sam make if he sold 250 cars this year? So what we would do is we now know what the x is, because 250 cars, remember the x represented cars. So I'm going to write, he's going to make $200 for every one of those 250 cars. So we're going to show that multiplying. And then when we do that, we'll add the $35,000, which is his salary no matter what. So I'll do 250 times 200, and we'll see how much he got from the cars. That's 10. Did I mess up? Nope. Oh, yep, I did. So there's 2 zeros there, then that 0. 2 times 5 is 10. 2 times 2 is 4, plus 1 is 5. So we got $50,000 from the cars, selling the cars. So really that's the most important thing, sell those cars, because $35,000 is his base salary. So he made $85,000 selling 250 cars. So let's look at the second example. The second example says last year Sam made $79,000. How many cars did he sell? Well, this time we don't know the x, which is how many cars he sold. I'm going to go ahead and erase all this. But we do know his total salary. So that is what the y is. So I'm going to put in his total salary out here for the y, is 79,000, and then we can solve for x. And this is just a simple equation. So we have that. So now I'm trying to find out what this is, so I get rid of the things with it. So the first thing I do is subtract $35,000 from both sides, and I'd get over here $44,000 equals 200x, and then to find out what x is, I need to get rid of the 200, so I divide 44,000 by 200, and that would be, cross off those 2 zeros, 2 goes into 440, 220 times. So again, we go back to the question, what were we trying to find out? How many cars he sold. So he sold 220 cars, turn a salary of $79,000. So that is how you do it. Again, y-intercept is the thing that is not going to change no matter how many things are sold, how many items are bought, how many whatevers, how many months, that kind of thing. That y-intercept is not going to be multiplied by anything. It's just going to be out there no matter what. Let's look at the next one. This one says, Jenny sold candy bars as a fundraiser for cheerleading camp. There were 2 types. The large chocolate bars with almonds were $3 and small chocolate bars with coconut were $2. She wanted to earn $500 for camp. Write an equation representing this scenario. So this time, this one's a little different. This has two things. We have the large chocolate bars for $3 and the small chocolate bars for $2. So we're going to be selling those. So we're going to be selling two different things, one for $2 and one for $3. So what we could say that the small chocolate bars are the X's, and we don't really know which one, it doesn't really matter on this one which one is X and which one is Y. So if I say $2 times X, that would tell us, this little statement right here would tell us how much money she made selling the coconut bars. And then if I added that to the $3 times Y, and if I say that the Y is the almond bars, then if I multiply 3 times the number of almond bars she sold, then this would represent how many almond bars. So again, I made the X the coconut bars, I made the Y the almond bars. 2 times the number of coconut bars would give us that much money for coconut bars. 3 times the number of almond bars would tell us how much money she earned with that. Now it says here that she wants to earn $500 for camp. So if I say 2 times my number of coconut bars plus 3 times my number of almond bars, and we want that to equal the $500 she earns, there's our equation. So this equation is written in standard form, and you do have a few like this, I believe. Think if there's something like where you have two different kinds of things, like children's tickets, adult tickets, those kind of things, then you're going to be writing an equation like this. So let's look at the question. Jenny sold all 120 almond bars that she had. How many coconut bars would she need to sell to earn the $500? So now we know how many almond bars she had. And if you remember, the almond bars were the $3 bars, so that goes in for the Y. So if she sold 120 almond bars, that's 3 times 120, because 120 represents the number of almond bars. Okay, so we still don't know the number of coconut bars, so 3 times 120 is 360. And we just keep solving this equation. So if I take 360 away from 500, I'm going to get 140, which tells us, if we divide by 2, that she will need to sell 70 coconut bars. So I hope that makes sense. I think you might have a couple where your whatever is in front of your X, like when we do one of these kind, whatever is in front of the X might be a negative, and that's if the price goes down or if something is decreased. That would make your thing in front of your X negative. I can't remember the examples on your paper, but just think about that. Think about if you're going to be taking that away from something else, then that's going to be a negative. Just think about what the problem is asking you. If you have any questions, let me know. You're going to have to type out the problem or part of the problem to explain it to me so I know exactly what you're having a question on. But I'd be happy to help you, so just let me know, and I'll see you guys tomorrow.